In this video, we're going to look at doing examples C, D, and E. And we're going to start looking at systems that do not have a variable eliminate just by adding the two equations together. For example, in C, if we just added these two equations together, we would end up with 5x plus 10y equals negative 15, and that really does not do us any good. Neither variable eliminates. However, if you will notice, you'll notice that 5y and 15y here, in one of the equations has a coefficient on a variable that's a multiple of the other. For example, 15 is a multiple of 5. Now, so what we want to do is rewrite these equations so that they have the same coefficient, just opposites on the y's, because one is a multiple of the other. So what we want to end up with is a negative 15y here, because now when we add these two together, those two variables now become eliminated. The y's become eliminated. So what do I multiply negative 5y by to get negative 15y? The answer is 3. So I'm going to multiply the entire bottom equation by 3, which is legal because we're using the multiplication property of equality. So when I multiply the entire bottom equation by 3, 7x times 3 is 21x. And then negative 5y times 3 is negative 15y. That's what we want to end up with. And then 17 times 3 is 51. So when we add these two equations together now, the y's become eliminated. So adding these two together, negative 2x and 21x is 19x. The y's cancel out, and negative 32 plus 51 is 19. Now when we divide both sides by 19, x is equal to 1. So that is the x-coordinate of our point of intersection of these two lines. And then we find y by substituting 1 into one of these equations for x. We can go ahead and substitute it into the top one. So negative 2 times 1 is negative 2 plus 15y equals negative 32. And then I'm just going to solve this equation now for y. First thing I'm going to do is add 2 to both sides. So 15y equals negative 32 plus 2 is negative 30. And then dividing by 15, y is equal to negative 2. And again, you can always check to make sure you got the right answer by substituting 1 and negative 2 in for x and y into both equations. So in this case, we have negative 2 minus 30. That is, in fact, negative 32. And in the second one, we have 7 plus 10. That is equal to 17. So this, in fact, is the correct solution. Now, in the second equation, we'll notice that, again, 6 is a multiple of 2, so we'll have a goal of eliminating the y's. So the bottom one will stay the same. 3x plus 6y equals 6. And then what we want up here is a negative 6y to eliminate the y's, because now when we add these two together, they cancel out. So what do I multiply negative 2y by to get negative 6y? The answer is 3. So then I multiply that entire top equation by 3. So 3 times 5x is 15x. Minus 6y equals 18. So now when adding these two equations together, I get 18x is equal to 24. And when I divide both sides by 18, I get 3 halves. 24 over 18 reduces to 3 halves. Sorry, it does not. It will actually reduce to 4 thirds, because 6 goes into both of those, not 8. So that will actually be 4 thirds. My bad. So the x-coordinate of the point of intersection is 4 thirds, or 1 1/3. And I'm going to choose carefully which equation I'm going to substitute that back in for. Because if I look closely, if I substitute it into the top one, 5 times 4 thirds would still give me a fraction for a solution. But if I substitute it into the bottom one, 3 times 4 thirds would eliminate that fraction, because 3 times 4 thirds becomes 12 over 3, or just 4. So that's in the bottom one, plus 6y is equal to 6. And then I can just solve this remaining equation for y by subtracting 4 first. 6y is equal to 2. And dividing both sides by 6, I end up with y is equal to 1/3. And again, I may write this out just to check carefully. 5 times 4 thirds is 20 thirds. 2 times 1/3 is 2 thirds. So then I get 18 thirds, which is in fact 6. So it checks out in the first one. It works in the first one. 3 times 4 thirds is 4. 6 times 1/3 is 2. And that is in fact equal to 6. So then I know that is the solution for that system. And finally, E, I'm actually going to do twice because E is not too bad using substitution either. The first method, if we go ahead and use substitution, I can solve this top equation for Q pretty easily by subtracting 3p from both sides. And then I can substitute that in for Q in the next equation. So I end up with 2p minus 2 times negative 3p plus 7 is equal to negative 6. So then 2p plus 6p minus 14 equals negative 6. And combining the like terms to get 8p. Adding 14 gives me 8 on the other side, so p is equal to 1. And if we don't have x's and y's, our ordered pair, we always put the variable that comes first in the alphabet first in the ordered pair. P comes before Q in the alphabet, so therefore P will come first in the ordered pair. And finding Q, we just can substitute 1 in for P here, so we have negative 3 plus 7, which is 4. Okay, so it worked for substitution. Again, we can check this. 3 plus 4 is in fact 7. And 2 minus 8 is negative 6. So 1, 4 is our solution. That's using substitution. Now another method, and using substitution for that was not too bad. We could have also used elimination for this. And 2 is a multiple of 1. So we're going to keep the bottom equation the same, 2p minus 2q equals negative 6. And we want positive 2q in the top. So now our q's will cancel. And the way we get 2q in the top is by multiplying the entire top equation by 2. So when we do that, we have 6p. 3p times 2 is 6p, plus 2q is equal to 14. And now when we add these two equations together, 6p plus 2p is 8p. Q's cancel. 14 and negative 6 is positive 8. So p is equal to 1. And again, p comes first in the alphabet. So we'll list that first. You see the pen there, but it's not writing. This is a little annoying. Okay, so we have 1 there. Finger works. And substituting back in to one of the equations for 3 times 1 is 3, plus q is equal to 7. And subtracting the 3 to solve for q, q is equal to 4. And again, just like we did last time, we already checked that, and that works. So that is multiplying one of the equations by 0 to, or multiplying one of the equations by a constant to end up with a variable that eliminates. In the next video, we're going to be looking at multiplying both equations by different constants so that we end up with eliminating one variable.